The second tenet of grease separation is flow pattern, how the water is moving inside the unit. The traditional design has been a baffle design where the water moves up and down over the baffles. And the thinking is that by elongating that water travel path, you keep the greasy wastewater in there longer and allow the grease and the food sediments to separate. And it does do that for the most part. Some of the drawbacks to it are that it also creates a lot of turbulence inside of there because of all those sharp turns. And when you have turbulence, you have the fats, oils, and grease and the food sediments still entrained in the wastewater flow pattern. And ultimately, that can lead to them exiting out the outlet, which is a bad thing. And we found, both our research and the Water Environment Research Federation, WERF, has found that baffle designs are inefficient in terms of their flow pattern. They create dead spots of no flow. And whenever you're not using that liquid capacity, that liquid volume in there for separation, then there's no reason for it to be there. And for all intents and purposes, it's just waste volume. This next slide here comes from the WERF F.O.G study. F.O.G is fats, roots, oils, and grease. This was something that was first presented at the AWWA conference about a year ago, I believe, or maybe in January. But basically what they found was the study took grease interceptors and they wanted to study how baffles had, what effect baffles had on separation efficiency. And so what they did was they took a 300-gallon box basically, and they set up the inlet and outlet piping in the baffles in different spots and measured grease collection efficiency or separation efficiency inside the unit. And ultimately what they found was that, surprisingly enough, baffles had an adverse effect on grease separation compared to more of an open design inside the unit, which is the same thing that Schier had found separately in our own study as we were certified by NSF to the ASME standard. So two separate organizations found the same thing. What we found in our NSF testing is that by moving away from baffles to a diffuser setup and engineering that flow pattern and paying attention to what's going on in terms of flow pattern, you can engineer a separator that more efficiently separates fats, oils, and grease without having to have a huge footprint. And that has all kinds of benefits for the end user and for the environment. Charlie's question was, state a couple examples of how a smaller footprint interceptor outperformed a larger footprint interceptor. Just recently, we completed a study in Branson, Missouri that had our 250-gallon grease interceptor, and it was paired against 2,000-gallon grease interceptors at restaurants with similar menus. And after 12 months of studying, they pulled samples and sent them to a third-party lab. And after 12 months of sampling, the 250-gallon unit actually had better parts per million effluent quality on the outlet than the 1,000-gallon grease interceptors. So that was one of the studies that was done. As far as examples, when we did our NSF testing to get our unit certified, we actually started out with a baffle design, similar to the baffle designs you've seen or that have been pervasive for 80 years. 5 minutes, thank you. And when we tested the baffle design, it actually barely met the standard minimum, meaning 2 times the flow rate. If you have a 25-gallon per minute interceptor, it has to have 50 pounds of grease capacity. We had a very, very hard time even meeting the minimum standard requirement with baffles. And when we, for lack of a better term, threw that design in the trash and started from scratch, ultimately ending up with the diffuser setup, the grease capacity not only hit that minimum, but it jumped sometimes to 2, 2.5, 3 times the requirement. So more hard data that design, an engineered flow pattern, and a baffle-less design can outperform what has been the status quo for 80 years.
So, just to give a couple of examples, when we tested our 25 GPM grease interceptor, instead of meeting the minimum grease storage capacity of 50 pounds of grease, it maxed out at 98 pounds of grease. So basically, we were accomplishing twice as much grease storage in a similarly sized shell. When we tested our 50 GPM grease interceptor, it efficiently stored 259 pounds of grease instead of 100 pounds of grease. And when we tested our 125-gallon 75 GPM unit, it stored 616 pounds of grease efficiently instead of 150. And our 250-gallon unit at 100 GPM stored 1,076 pounds of grease instead of 200 pounds of grease. That's where the rubber meets the road. The whole point of having these products is to separate grease and retain it within the grease interceptor. And what we're saying is we've proven that excellent grease storage efficiency can happen in a smaller footprint design, given the right design. That can save municipalities, can save end users a lot of money for a much better, tighter footprint product.
Some of the things that the presentation touches on, and I encourage you to look at it after we adjourn, is some of the materials and that are used, some of the designs, and the last part of the presentation actually touches on the FOG, jurisdictional FOG dynamic across the country, something that Charlie was touching on, and the overlapping jurisdiction and just some of the confusion that's created about by having multiple standards, multiple jurisdictional authorities, and some of the basically just an explanation of the dynamic there. Solid storage capacity was something that was definitely considered in our design. The way our diffusers are set up, it allows for a large amount of solid storage. How much? It's not covered in the standard, unfortunately, so there's not a number that you can publish and say this much solids. But
if the garbage disposal was tying in the line, we definitely recommend the solids interceptor for pre-treatment prior to the grease interceptor. But a lot of municipalities, states, counties don't allow those to tie in to a grease interceptor. There's pluses and minuses as to why, but so yeah.
Correct. The comment was that the term hydromechanical grease interceptor is one that is become widely used for the smaller interceptors, and actually terms like hydromechanical and gravity, different terms for basically the same design, which is gravity separation, are one of those things that further leads to confusion, we feel, and something that needs to be hammered out in the industry. Thank you.
Thanks for your time.
Thank you.